Okay, hi everyone. Happy to see you back on our user meeting, which is number 16 now. In today's agenda, we have 4 different topics. First, I will describe our new compute environment, which is the environment for scientific computing that lets you productionalize your scientific code written in R, Python, Julia, C++, almost any language super easily in minutes. Then Victor will expand on that, providing a great demo on a real life use case that we built for one of the big pharma companies. Well, a simplified version, of course, but there's some interesting computing involved. Then we will present new feature in the DataGrok platform, well, new capability, the ability to work with those response curves. Dmitro will talk about that. And lastly, we have a bunch of really interesting improvements in the cheminformatics space, and David will take care of that. But let's get started. So let's start with compute. So as you know, DataGrok supports multiple languages out of the box, and almost everything is a function in DataGrok. Now, what we have done is we provided the ability to define functions or scripts in any language, and then in a super lightweight way publish them in such a way that they are available to all users. And they become almost interactive applications with you having to write absolutely no user interface code. And now I will explain how it all happens. Let's start with a very simple case. A function, this one is written in Python, that renders electronic density of a molecule. This is the Python code, and this is the header. What's interesting here is that we have an input defined here and an output, and the script manipulates them. When you run this script, what DataGrok does is that it automatically renders the user interface for the invocation. So this is the integer parameter contours, and this parameter has semantic type molecule, so it actually allows us to sketch it. So we would change our parameters, and now we would execute the function. It is Python, so it's executed on a server. It took half a second, and we got our beautiful picture with electronic densities. We really dealt with absolutely no UI here, and we ended up with a form that you can fill in a smart way and get a result. So let's make it more complicated now. Let's take an example of a model which actually describes the dynamics of praise and victims based on different parameters. It's called Lotka-Volterra model. We have a bunch of inputs. Well, let's execute it. What you notice is that it shows up in the view this time, and it executed immediately. What we see here is again the same set of inputs that is automatically created and automatically positioned in the end. And there is an output that has a graphical representation. But why does it have this graphical representation? If we go back to the script, we see that the output is annotated, saying that it should be shown as a line chart with a multi-axis and the following title. So this is all it takes to produce that sort of well, interactive application. What we get from here? So first of all, we can modify parameters, and as I type it, or I can use also scrollers and other inputs, it gets recalculated in real time. This model is fast, so we can allow to recalculate it as we drag the slider. Then you can save a particular run of the model, and it gets stored in your space, which can be shared with your colleagues. So out of the box, we get the capability to play with the model, publish it, share with other users. You see, this is the custom URL, and track different runs. And obviously, we can easily, with one click, switch between different runs, which is important for modeling. Sometimes you will find a really interesting combination of parameters or just something that you want to produce and share with others. It comes out for free out of the box. Other different features include saving the parameter models and pictures to Excel, to other formats, marking different runs as favorites, and so on. And really, if you think about it, a lot, many universal and important things could be applied universally to a function. And now I will list the features that, again, you get from Datagrok platform for free once you publish your function. So you only have to deal with the actual mathematics, the actual computations, and then just apply minimalistic annotations to parameters and get working applications. First of all, we support multiple languages. So we are not like R Shiny. You can write your code in any language, and bam, you get a working application. The computations are scalable. Datagrok takes care of the infrastructure. If necessary, it will be spawning multiple machines and Docker containers. The user interface is generated automatically, and it's pretty rich. As you will see later in the presentation, we have it's adaptive. We have multiple input types, multiple validation options, multiple ways parameters can be defined, and so on. If necessary, there is a way to make the user interface completely custom while still preserving the functionality, the universal functionality. Well, obviously, Datagrok is a web application, so you get that sort of rich modeling environment on mobile applications. Here's me using it on the ancient Nexus, I think, tablet. You get a well-defined life cycle of a model. since everything is so simplified and the model is the actual computations, now you can split it into separate stages. So you know where you develop it, how it gets published, which version are you using, how it gets promoted to deployment, and so on. So the life cycle is fully managed. Deployment is simple. Multiple options here. You can just go ahead and write a function yourself and click save, and you get it. For more serious development, you would develop your models computations in a package and deploy it to Datagrok. So you have complete control over how formalized it has to be. For Python and R, we provide support for different environments. I'm already anticipating this question. And by the way, please interrupt me at any point of time if you have questions. It's easy to share either models as a link to an application or a particular runs. Since Datagrok is a universal data platform, we went ahead and integrated this computation capability with the data access capability, which is super important because you don't work in a vacuum, you work with data in order to, and you have to get it from somewhere. In our previous meetings, and we've discussed the data access capability, so you're probably already familiar with the concepts of connections and queries. Queries are also functions, and this is how you can combine them super easily. So on this screen, we have first we have an example of a query that gets some powder information based on the metal that you are entering, and it returns a data frame. So this is strictly a SQL script that also becomes a function. And then we have the actual computation, which is written in R. And one of the computation parameters is the input parameters is the data frame. And for that data frame, in the input annotation, we specify that this function that we defined previously produces this parameter. And this is all that you need to write. You need to specify the editor and put the query name in here. Now, what's going to happen, instead of the usual input control for data frames, it would get expanded with the parameters of the query. And this is how it would look like the whole application. So the first two parameters, they are inferred from the editor. They define the database query. The second parameters define the computation. And it's seamless, and in the end you get an integrated application that lets you parameterize your input, and when you click run, first the query gets executed, the data frame gets retrieved, and then it's passed to the computation function. And this is a super typical use case in real companies. You have to get data from a database or from some data source. You have to transform it, produce something, and you have to visualize the results. Now you can do it all without having to write a single line of code for the user interface. It's all logic for retrieving the data and the logic for transformations. The rest is covered by Datagrok. Reproducible computations. That's a very important concept. You obviously want to be able to, well, reproduce your experiments. And since everything is managed in Datagrok, you get it for free, out of the box, I mean. Since we split everything to computations and user interface, everything is versioned, so you know exactly what was executed to get certain results, and you can rerun the computations. Because of that separation, clear separation, we are also capable to do plenty of optimizations that affect the performance, such as automated caching and so on. In order to work with scripts and models efficiently, we've also improved our model browser. So now you can search by tags, by text, by any attributes within your scripts or models, and even you can have different hierarchies. So now it's very simple to manage it. And actually, one of our biggest projects is with one of the big pharma companies. Probably some of our colleagues are here on the call. And there we have plenty of models, so users can come and see what's relevant for them. In addition to all of that, we can also introduce universal analytical blocks that would work with different functions. So things like detection of outliers or sensitivity analysis or exploration of different parameter spaces. These concepts and these approaches are universal. They are applicable to every function. And this is exactly what we are doing. In the next presentation, Victor will show some of the capabilities that this feature unlocks, where you start with a function and then you start exploring it in different ways. A couple of other benefits that you get is the automatic integration. So you get your function that produces some results. Well, now you can use it through the REST endpoint. This is it, no fuss. Or you can call it from JavaScript API if you want some tighter integration with Datagrok. Or you can embed it as an iframe in the external website. Logging, audit, and traceability are also core features of the platform that are utilized in compute. So if there is a need, you can turn all of these switches on, and you would get complete picture of what and when and by whom was executed, and you can even look at results. So that's important, for instance, for modeling. We often hear from our partners that, for instance, lately you want to make sure before synthesizing some compound that in silico modeling was performed. And this is one way to establish it. You just look at the audit and you see what was executed, which model against which molecule. And of course, you get the exploratory data analysis. This is where Datagrok shines. So you can right-click on any results that modeling produces, and, for instance, open the data frame in a full data group workspace, and then start exploring, slicing, and dicing, and visualizing the way you want it. One last thing that I wanted to show is just the different how rich the user interface can become without having to write any user interface. So here we have different parameters with different layouts, with units. Some things are collapsed in panels, different sections that appear depending on other parameters, and all of that is done by annotating the parameters of the script. We also have a visual editor for it, but let's not describe it today. So to sum it up, you write a script, a computation, and in a minute it gets deployed and productionalized. This is as easy as it is. Any questions before we move to the more involved use case?
So when you add when you run another say run, and it goes into the history, does it also add a row to the data frame? And then can you look at multiple rows in the data frame? It's like Lotka-Volterra example, for example, it showed we were looking at one row, right?
Mm-hmm.
And then, but
so the run saves all the parameters that were used for computations. If one of the parameters is a data frame, it will get saved. You can control whether it gets saved as a static snapshot or a dynamic link, I think. But yeah, that's the idea. It's completely reproducible.
No, from what I thought, the inputs and outputs just become values in a data frame, huh? And that's what you visualize.
No, not necessarily. So you can have multiple input values, which can be of any type and any number. But also the output parameters, you also can have multiple output parameters. You can have multiple data frames or a combination very often of data frames and scalars. And you will see it in Victor's presentation later. And yeah, all of that is saved when you really want to save the run.
Okay, thank you.
Okay, thanks. Victor, please take the stage.
Hello, Andrew. I need permission to share my screen.
Right. Yep, you are the host now.
Thank you. I hope you can see my screen. Yes?
Yes.
So hello everyone. I'm Victor, a data scientist at Datagrok with PhD degree in physics and mathematics. That's why I'm really excited about today's topic. So Andrew just showed the concept of modeling. And I will show how you can use Datagrok to model complex processes and solve differential equations right in the browser. Consider the following problem. Here is some specific system of ordinary differential equations. This system specifies some specific kinetic mechanism, and one may try to solve it manually, but it is too complicated. At the same time, a naive approach requires a huge amount of computations. In order to solve the problem of complexity, we have implemented the concept of WebAutoSolver proposed by our principal research scientist, Leonid Stolbov. This tool takes differential equations in the declarative form and automatically generates data grok function, including its inappropriate annotation. Let's check it. Let's go to the model catalog. Here is our bioreactor. By the way, this is a simplified version of the real use case, which is used by one of the biggest pharma company. Let's run it. By the way, this user interface is generated automatically with respect to the inappropriate annotation. Here we specify time of modeling, initial values of the process, and parameters of the model. Run computations, and we have got numerical solution and graphs of functions that describe the process. Let's change inputs. Maybe this one, another one, and maybe this one. And we see that each time we modify inputs, we obtain different results. In order to study this dependence, we can use data grok sensitivity analysis feature. Let's use it. Actually, using this tool, we can explore model. We can investigate dependence of the model outputs on its inputs. For example, let's study variation of the first initial value within the range specified. Let's take 30 points. Now we explore the final point of the process, run computations, and we have got numerical results, a correlation plot that provides a birdwatch view on the results obtained, and line chart that shows us dependence of outputs on the first initial value. Consider another approach. For example, let's apply the Monte Carlo method. Now we evaluate our model for 100 times. Let's explore variation of two initial values. Again, run computations. And we have got, again, numerical results, a correlation plot. And by the way, here we can see some very interesting dependencies. And also we have got a scatter plot. Each point is colored with respect to the specified output. Let's vary it. And we can see and we can explore our model output. Consider, for example, I don't know, maybe this big red point. Click on this row. And here in the context panel, we obtain the corresponding solution that corresponds to these inputs. And by the way, this tool can be used and can be applied to each data grok function. And as you can see, we can grok any model using this approach. So now we work on improvements, and soon we will implement more methods for sensitivity analysis and function optimization. Also, we will provide tools for solving the inverse problem when the initial point is obtained with respect to the desired outputs. So that's how DataGrok provides complex modeling in the browser very fast and simple. Thanks. I will be happy to answer your questions.
Victor, what sort of tasks it could be applied to?
This, first of all, we can use WebAutoSolver in order to solve systems of ordinary differential equations, and such systems can describe a great variety of processes, starting with controlled Fab-arm exchange and I don't know, maybe some QA and modeling systems. So if we get system of differential equations, we can process these equations using our WebAutoSolver. We obtain data grok function, and then we can run this function in the platform, and also we can solve sensitivity analysis tasks. And by the way, we can solve using our tools. We can solve as stiff or as well as non-stiff problems. So, and for this purpose, we have implemented several methods. By the way, user can.
I think I missed. Can I specify my own ODE system to solve?
Sure. You can. Sure. We have implemented the WebAutoSolver. You can define. So if we have time, I can show you this process. And do have we time?
Yeah, you can explain it in a minute. But yeah, essentially, you provide a symbolic representation of the system to solve, and then we run our magic autosolver, and it generates a highly optimized solution through generating C++ code and then compiling it to WebAssembly. But the end result is that, yeah, we now solve it in milliseconds, what used to be minutes in Python.
By the way, maybe a few words about WebAutoSolver. Here is its scheme. So it takes differential equations in declarative form. So just equations, no code at all. And then it automatically, first of all, generates C++ code. After that, it generates rich function view annotation. By the way, this annotation is used in order to build user interface. After that, it combines it with our ordinary differential equation solver, and then it produces WebAssembly code. Then it combines it all together to the package code, and this already and this ready for publishing package now can be used in the platform. And actually, that bioreactor, this one. Sorry, this one. It's data grok function created in that way, totally automatic, just using that equations, no code.
Yeah, and the beauty is that all of that black box is hidden from the user. So you go from your set of differential equations to the working application without having to write user interface code. And also, I just want to underline what Victor already said, the sensitivity analysis approach. It works with any script, any data grok function. It's not specific to the differential equations that Victor was showing. We are just combining two examples altogether.
So we can consider, for example, this classic example, so-called Ishigami function, run computations, and we see that with respect to the first input, it's something like sine function. Maybe if we consider another input, again, let's run computations, and we can see some other behavior. So maybe it's some polynomial. Yes, also we can consider all three, I don't know, maybe these values. And if we run computations, now we can see something like this. Yes, and we can see dependence of our output with respect to x1, x2, and each point is colored with respect to x3. So we can grok this model using all powerful tools of our platform. By the way, we have also other methods. We have also the Monte Carlo approach. You have already seen it. Yes, when we have considered bioreactor, and also we have implemented the Sobel method. And this method is very useful if you want to study variation of the model's output with respect to each input alone. And you can obtain, for example, some numerical indicators. And let's consider this one, run computations. And here we have got Sobel indices. And these indices show us that the first input is the main one, and all other inputs are not so. And that it's also Sobel method. Further, we will implement more methods, in particular the Maurice method. That's about our plans.
Okay, great. Yeah, thanks a lot, Victor. That was fascinating. I am always fascinating at what you can currently do with the browser, and yeah, happy to help to push the boundaries in this case. So next up is Dmitro, who will tell us about those response curves. Dmitro, take the stage, please.
Yeah, let me share the screen. Okay, hello everyone, my name is Dmitro, and I'm a software developer at Datagrok, and today I would like to show you the dose response curves application. This application provides us a convenient way to work with the dose response curves just in the Datagrok interface. And I will show you it with our demo application today. So let's find the curve fitting app. Let's close this one. And what do we see here? We see here a molecule column and many different other curves column. The first and main benefit of our curve fitting model is that we don't need to go to some different applications like GraphPad or other. We can just have the molecules values here and see the curves for these molecules, compounds, and other things. So let's try to, for example, change some widths and heights of the columns. For example, this one, as you see, it renders the title of the curve fitting plot. So what are these columns here? These columns are different sets of curves. The first one where we have the prefitted values. That's in this case, we have the prefitted parameters of curves. And we don't need to make a fit to render them properly. And other columns that are different styled columns, columns with candlesticks, and even custom fit function columns. So let's start with the first one, and let's try to change some properties there. For example, I know marker types. As you see, it updates. It's also some line styles and I think drop lines. So one of the also main things is that we can render the drop lines. Right now it's the IC50 value for all curves, so you can easily track what is IC50 value for your curves. And also let us change some plot axis value. For example, something like this, and it changes for the whole column. Also, we can control it on different levels. It can be the column level, data frame level, or even just the cell level. Let's look at another column, this one with the candlesticks. Right now it's logarithmed, so we can untick this value, for example. It won't be logarithm now. And you can even set the custom chart options. So if you have a situation when you have different curves with different X and Y values, but you want to compare them one by one in the sets of the column, you can just set the mean and max X and Y parameters, for example, 0 and I don't know, the 10, and you will see that all of the plots in the column are converted to one mean and max values, axis values, so we can easily compare them. Also, the last but not least thing we made in the curves package is the custom fit function. So right now our curves support the sigmoid fit function, but there are cases when the users would like to use their own fit function. And for this, we have a little snippet of code on our documentation where we can write down our own fit function just as an arrow JavaScript function and use it. And in this case, we just have this polynomial JavaScript function. And as you see, it's also fitted and rendered the same way as the other curves. So we can easily switch the mode of showing, for example, to show the points, not the candlestick or other modes. We would like to show or not the curve confidence intervals and other ways, other things. Also, we've implemented a capability to store the statistics in specific columns. For example, we want to store the area under the curve statistic of this column. We will add it, and we added a column to the grid. And if we, for example, would like to switch some outliers on the curve, by the way, we can do it right in our data group grid. So we just have to switch the click to toggle mode, and let's click on different points. And as you see, the curve plot is refitted and re-rendered, and our statistic values are updated as well. And I think the last one I wanted to add there is I think a viewer which is called multi-curve viewer. We're developing this viewer right now, but the sense of this viewer is that we can compare different plots rows, different grid rows which have the plots just on our one viewer. So for example, if we will take show selected rows curves, and we will select some of them, as you see, they are all rendered together, and we can easily see what happens there. Coming back to our curves, all of them are stored as a JSON with different series, and every series have many points. And all of this you can also find on our documentation. I guess that's all regarding the curve fitting. So if you have some questions, I would like to listen and answer you.
So what if the rows are not that tall? Will I still be able to see the chart?
Yeah,
So
sure.
Yeah, you have a lot of them.
Yeah, we can also just make our columns much smaller sizes, and as you see, all of them are rendered, all of them in this small format, but you can also see the shape of the curve, you can analyze it, and it's very convenient way to work with the curves as well. So you can, at the same time, you see the compound, you see the curves, and it's, okay, so we take this shape maybe it provides us this and this information. Yeah, sure.
Thanks. So what are the next areas for improvement here?
Yeah.
What we're gonna build?
Yeah, okay. Our next features that will come soon, first of all, it will be the edit mode of the curves. Right now, if we double click on the curve, we'll have an edit chart window. It isn't right now implemented correctly, but we'll work on it so you can switch the series one by one and control them more precisely just in the edit chart window. And the other thing we would like to work with is a multi-curve viewer to provide a more convenient way for users to compare the curves they have. That's our nearest priorities. By the way, I also forgot to tell that the curve fitting package is already used in the production by different pharma companies, even one big pharma company and other different startups. I guess there are even some participants in this call that are using the curves. So I think that's all from me, and I'm giving the stage back.
Okay. Yeah. Thanks, Dmitro. The next and final presenter is David. So let me make him a host. You're a host. Please take it.
Thank you. Hello, everyone. I'm gonna be showcasing today a couple of new really cool cheminformatics developments that we had and what our team has been working on. Can you see my screen?
Yes.
Yeah, it's cool. So the first one is gonna be about the highlighting of the substructures. So if you have a data set containing molecular columns, in the context menu on the right of this molecular column, down in the chemistry section, you can now see the highlight subsection in which a user can draw different substructures, and those, if contained in any of the molecules in the data set, will be highlighted in the color that is chosen. So for example, if I choose a benzene ring and I assign a green color, every molecule having a benzene ring in its substructure will have this substructure highlighted in green. We can add some other things. So for example, let's say cyclohexane with oxygen, hydroxyl group, and let's say highlight it in blue. And we can find any there. So here we can see that these substructures are highlighted, and these substructures can be added for quite a lot of amount. So we can add pretty much as many as we want. So for example, just an azide group, for example, there. Or so on and so on. So I'm going to be showing some other features as well. Do you have any questions with that? Okay, cool, thanks. So the next one is going to be the hierarchical clustering of molecules. So as you probably know, we have this feature for numerical values, and we also had it for biological sequences like protein sequences or DNA RNA sequences. And now it's also available for molecules. And the way it works is For every molecule, we calculate the fingerprints of those molecules, and then we compare the pairwise distances and then build a hierarchical graph that is going to be shown here on the left side. So in the Chem top menu, in the Analyze section, there is going to be a option for hierarchical clustering. We can choose the molecular features that we want, and we can choose different metrics such as the linkage. This is used for the clustering itself, and the distance for the clustering as well. And once we choose it, in the data set of 1,000 molecules, as you saw, it took just 1 second to build a hierarchical graph. It sorts the molecules according to the graph itself, and you can visualize that very similar molecules are very close together and so on. And this data set can be also contracted like this to see a bigger picture, though the molecules are not going to be shown that good, but this is it. Yeah. Any questions with this?
Very cool. If you click on a tree somewhere up the tree, can you see the common substructure?
Not yet, no, but that's a really interesting idea. Thank you. But as I said, they are not. We can implement something like calculating the most common substructure for the given selected rows. But when you click on the header of the connection, so for example, this one on this node, it will select everything that is coming out of this node. But as those are not clustered together by a substructure, but rather by the distance of their fingerprints, molecular fingerprints, it's not, if you, for example, select some node up high, it's not necessary that they will have a common substructure. Always. So.
Still good if you could show that in the panel on the right, would be useful, I think.
And that's a really interesting idea. Thank you. Okay, shall I move on? Okay. And lastly, one really cool addition that we had. If you remember, for molecular columns, we have a substructure filter, which basically, when you draw some chemical structure, it filters out the molecules that contain this substructure. And in the previous version, we had it so that when you draw a structure, the filter needed to finish until you drew a new one. But now we have basically cut it down in batches. So the initial results from the filtering are shown immediately. And also, once someone changes the query molecule that we are searching for, the results are changed immediately as well. So I'm gonna showcase this. So for example, in this scenario, we have about 2.5 million molecules from Campbell database. And if we query for a benzene, you can see that the results are immediately shown. The progress is going, and for each progress step, which are quite close together, the filtered molecules are to be added to the database. And once the first progress has finished, that means that the fingerprints for all the molecules have been calculated, and the subsequent search are going to be pretty much instantaneous. Because the preliminary step for filtering is matching by fingerprints, and if they don't match, then we don't take them to the subsequent substructure search. And this saves a lot of time. And even on the data set of 2.5 million, it can be very, very fast in a matter of a couple of seconds. What I was talking about, the termination of previous search and the starting of new one, you can see that the progress is going for the benzene ring, but if I draw an additional carbon onto it, the filter is changed immediately, and the filtered molecules are also changed immediately to search for the toluene molecule that I drew here. At any time, the search can be terminated with just cancel. And in case of big data sets, as we are saving the progress at every step, and for some of the molecules, so in this case, it went to about 10%. So we calculated the fingerprints for about 10% of the molecules. And the next time we start to search, those 10% of the fingerprints will also be cached out and used to speed up the, in this case, well, first 10% of the search. You can see that the first 10% goes really, really fast. So any questions with this?
That's super impressive. So that's the whole Campbell you have here, completely in the browser, doing
as far as I'm aware, yes. I did download it from Campbell, yes.
Can you do a little bit more? Just start drawing a molecule and see how quickly it reacts.
Of course. So
benzene. Yeah, a second, sub-second performance. So you don't get all the results at once, at least until the fingerprints are calculated, but it lets you iteratively look for your structure and immediately see the first hit. So I think there's a lot of value in that. Oh, this is nice.
Yeah, you can see this addition and elongation of the data set here, that the new results are just added down. And should mention, there is no flickering effect. It just continues. The new rows are going to be added at the bottom at their corresponding place. Okay, I guess with that, my presentation is over. If you don't have any questions, thank you very much for listening. I'll stop sharing now.
Okay, and we are right on time. Yeah, thanks a lot, David. Yeah, that was cool to see interactive search in millions of compounds. Yeah, we are right at the border of an hour. Thanks everyone for coming, and I hope to see everyone next time in 3 months. We will share the topics in advance, maybe in a month when we know them. Thanks again, everyone, and have a great day. Bye.
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 Thank you.
Thank you.
Bye.
Bye.
Thank you. Bye.
Thank you. Bye.